Tony, you're the man. All right. He's a big fan of my YouTube videos.
Okay.
All right, kids. We've got like an overview now, ish. And by no means do I expect you to have all that stuff at the forefront of your memory right now. I mean, I'm not one of those profs that expect you to have everything like this upon. We're going to keep revisiting those ideas as the course goes on, and we'll drill them into you eventually, but we'll drill slowly, and you won't feel the pain that way, which is nice. So what I want to get into now is a little bit more of organizing data. We know what data kind of is. We know what kinds of data we can have. But once you have it, what should you do with it? And that is really what the next 10 or even 20 weeks is all about, 243 and 244, what to do with the data when you have it. So I made up some fictitious data here just to kind of get some ballpark data out there. And suppose we have a small company and we keep track of how many products each of the 20 employees of the company create in a week. And these are the results that we get. It's a little hard to see. That's a 17, I believe. And that's an 8. Yeah, it's a 17 and an 18 right there. This is what I call raw data. The statistician keeps track of the number of products and gives you an unordered list just like this. That's the data. That's raw data. I beg for this when I read research articles. I really always want to see raw data. And a lot of times you won't find it. My most recent hunt is for the power bracelets. I want to get the raw data from that. Maybe you've heard of the power bracelet. There's these little bracelets you can get. They're copper or something, or a magnet or something. They're supposed to increase your athletic performance. Like you make you jump further, jump longer. And I saw these ads for them, and I thought they were hilarious because basically it was this big muscular guy saying, "You jump," and then this little scrawny guy would jump, and then they put here's a power bracelet. They put the power bracelet. Now jump again. Now what the hell's going to happen? The kid's going to jump further. Because he's got some guy yelling at him. He got to jump once so he knows what it feels like, and then he can go better the next time, right? So a study was done by a statistician to test the efficacy of power bracelets, and no surprise, they don't do anything. But I haven't gotten the data. I want to see the raw data. All I've got is the conclusion and the test statistic from the result, but I want the raw data. Now, it's messy. It's messy. This isn't the best way to present data to, say, a non-statistician. Why? Why is that kind of hard to look at?
Don't know what you're looking at, really.
Yeah.
Well, yeah. I mean, what are you looking at?
No idea.
What? No idea.
Clusters are not self-evident.
Clusters are. Oh, that's awesome. Clusters are not self-evident. If there are clusters, they are by no means obvious here. Is the minimum value obvious?
Yes.
Yeah, you can go find that. Is the maximum value obvious?
Yeah.
Upon scanning, you can find all that. Suppose there were 1,000 employees versus 20. It would take you longer to still do it, but the clusters would still be hidden in there. If there are clusters, maybe there aren't even clusters. Maybe it's non-uniform. Who knows? Or uniform. Maybe it's non. Maybe it is. I don't know. It's hard to look at like this. So, an advantage to raw data is there's no question, assuming it was collected correctly. And let's make some assumptions. Let's assume that all these products are the same. Let's assume that the person that's making 10 and the person that's making 30, this person is actually making 3 times as many of the same product as this person over here. Let's make that assumption. Like these aren't 3 times as hard to make, which is why they're making 10 to 30. I mean, that would be logical. But let's assume they're all making the same product, and that's what they've got. So the clusters are not self-evident. The min and max might take us average number of products. Average number per the, is that obvious at all? Not to me. I mean, I needed some kind of organization. So one way would be just to do what?
Put them in sequential order.
Put them in an order. Absolutely. Take those 20 and put them into an order. And there's nothing wrong with doing that. We'll come back to that momentarily because that is helpful. But there's no name for that other than just sorting. And Excel does a very good job. Your TIs do too. We'll play with that probably on Monday. One way to organize it, though, is to take your raw data, which is down here, and to not only put it in order, and throw your pen, not only put it in order, but also to put them into classes. Now, the selection of classes is not at all obvious. It's not at all obvious which class width to use. I'll come back to that momentarily. But I decided to use a class width of 3. So 10, 11, 12, 13, 14, 15, 16, 17, 18. I label my left column number of products. Do you guys see why there's a frequency of 1 in 10 to 12? Frequency is just a fancy statistical term for a number of occurrences. So how frequently does that occur? Do you see why it's 1 from 10 to 12? Because there was one data point that was a 10, no 11s and no 12s, so that means there was 1 in that range. 2 from 13 to 15. Can you go find them as well? Let's see. There's a 14 and a 15. There's our 2 there. 5 from 16 to 18. 1, 2, 3, 4, 5. There you go. Excel's got great functions that do this automatically for you. You'll learn them as you go through this course with me. Your TI does it automatically as well. We'll learn those as well. So it's tedious to do it manually. Also, there's no hard and fast rule as to how wide you should make. I mean, I went 10 to 12. Why not go 10 to 13? Right? Why not make them 4 wide instead of 3 wide? Nobody says you can't. You won't have as many then. So what a lot of times people will say was, okay, I want to have 10 groups. And then you can figure out, if you know you want 10 groups, you can figure out how wide to make them by simply going high minus low divided by 10. And that'll tell you how wide to make it. But don't worry about that. That's not important right now. And you can't learn that effectively in 10 weeks. So if I ever make you do one of these, I'll tell you how wide to make them. And if you get into a class where you're presenting data more and more and more, you'll learn this kind of thing. It's not a 10-week thing, and it definitely isn't a 1-week thing within 10 weeks of a thing. The more important thing is, do you know what you're looking at? And you do. Is Madeline's concern taken care of here? Her concern was that the clusters are not self-evident in the raw data down there at the bottom. Are they more evident here? Yes. They are definitely more evident here. They're definitely more evident because you're starting to see these clusters. Look, there were only 20 people in this entire study, and half of them are between 16 and 21. That's pretty awesome. That's awesome to know. I don't know if that's awesome. It's awesome to know that. That might be terrible. Maybe we have to put out 40 products a week and we suck. But at least you know that you suck and you can fix it, right? I mean, that's the whole point. That's kind of what statistics is partially based on. Can we analyze our results and actually, it's amazing to me. I never saw the movie Moneyball, but I'm slowly reading the book. And apparently, using statistics to make baseball purchases is a relatively recent phenomenon. We're talking about a sport that's a century and a half old. Is it baseball? Maybe 2 centuries old. And so much of scouting was based on, yeah, that guy looks great, looks like a baseball player, looks like this, looks like that, he can hit the ball. And they didn't analyze anything else like the percentage of times he got 3 bases on a bat versus 2. All these little tiny statistics that were never looked at before. In a sport where you're paying, how much are these salaries? You know, multi-million-dollar salaries sometimes. And I think that was why statistics are now used, is now that we're paying these guys multi-million-dollar contracts, they better actually do something besides take our money. So, or not our money, but whatever money. I guess they are. If you guys buy their stuff, I guess that is your money. So anyway, point being, that might tell us something. If those clusters are around 16 to 21, maybe we want to be up here, and this gives us at least an idea that we're not there on average. Good. Good. What's the problem with this? There is a problem with it. There are a couple problems actually. What's one? Let me ask a more specific question. How is this better than this? So how is the raw data better than the group data? What do you think, Srini?
Exactly how it's split down.
Yes, you do get the exact values, and Tiffany's going to tell me that when you know there are 5 16th 18s, but are they all 16s? Are they all 18s? I mean, no, without let's cover that.
Yeah.
Right, you don't know that, right? But we have a solution for that. Give me next class. We'll work that solution out. It's called the law of large numbers. It's a law. It's not a theory. It's a law. We'll work that out. That's good. And the other reason it might not be the best way, besides inexactness. Oh, maybe you don't see. Okay, that's okay. Look at that, and look at that. Which do you prefer? Which do you prefer? You prefer this? Christina says, yes, I vote for this. Why, Christina? Why do you vote for this?
Because it's a lot more visual and self-evident than just looking at the frequency and numbers.
There's a second dimension in this that is not present here. A 0 and a 5 take up roughly the same amount of space in a frequency distribution, right? This is a frequency distribution. They take up the same amount of space, a 0, a 1, a 2, a 3, a 4, a 5. Down here, a bar takes up 5 times as much. And that's good, because we are visual creatures. Very often you get these graphs that accompany the news. So yeah, you're getting the exact same data presentation in that bottom histogram as you were in the above frequency distribution. But go ahead, John.
Frequency also, I mean, depending on what you're looking at, could be in the reverse order, and you might not pick it up. Like a 5 could be worse than a 0. Like the scale could be flipped.
Good for you. I love this. What John is talking about is Likert scale type data. Like for example, when you rate like a pain scale.
Right.
Like how bad do you hurt? 1 to 10, 1 being you're fine, 10 being excruciating. Believe it or not, that will never be in the frequency column. That will always be in the left column because that actually is data. Believe it or not. I know it doesn't seem that way, but that is any information you collect, and that is information you collect. You ask the patient how much are you hurting.
Right.
I'm at a 9 right now. Give me morphine. That's data. Now you may have 20 patients voting 9, so it would be 9, 20, because 20 of them are voting that 9. Does that make sense, John?
Right.
That's a great point. And Likert scale data is tricky. Can I take a little aside here and talk about that? I'm glad you brought it up. Likert scale data is tricky. I keep using this phrase Likert scale, and I think did you guys had asked about the class evaluations last class. You did. One of my stat classes did. I did one before. When you guys take your class evaluations, you vote, and some of them, 1 to 7 or 1 to 5 or something like that. 1 strongly agree, 5 strongly disagree, or something. I forget which way it goes. Just like you said, it could be reversed. You've got to be super careful when you analyze those results. I love the results from those. I do. I love looking at them and kind of seeing patterns. But the trick with those is, what is a 9? Is a 9 for you the same as a 9 for me? And the answer is probably not. It's probably not. And the only thing I can do is I can suffer pretty well. So it might take me longer to get to a 9 than somebody else who doesn't suffer as well. So if I say there are 20 people all voting 9, I might be losing something in that measurement. It might be better to actually measure something like blood pressure or eye dilation, something that you're not thinking about your response to. Does that make sense? So I will come back to Likert scales because I have a love-hate relationship with them. Love the data that they get and hate what people do with them generally. So we'll come back as the course goes on. Thank you for that though, John. Rest easy. You're never going to get it because your data will always be on the left-hand side. So it might be for you 1 to 3, 5 to 7, 9 to 11. I'm skipping here, but that's what you're going to see on your left, and you'll have the counts on the right. Cool? Ish. So do we like these better? I think most people do. I think most people like these better than this, just because you can process more. You get the exact same data, but you get that relative. Yes. Oh, say that again.
Much faster.
It is, isn't it? You can see right away that the cluster is a cluster. It's not just a number. It's a boom. It's right here. Look what's going on here. This is kind of cool. Could this be fluky? Yeah, absolutely could be fluky. Or it could be something else. Or it could just be this gap here. I love the gaps. That's kind of nice too. There is nothing here. There is nothing here. What's up, overachievers? Why are they overachievers? I don't know.
They might be the most seasoned employees.
Maybe those seasoned employees drinking a lot of Red Bull. Who knows? Who knows, right? Maybe they're churning out 39 products, but they all suck.
Yeah.
Right? This is only measuring number of products, right? Quantity, not quality. There's a whole other series of measurements we haven't even done yet. So yeah, maybe the most seasoned employees. Therefore, they've gotten more efficient. Who knows? I mean, sometimes statistics raises more questions than it answers. But at least we've eradicated the worry about the clusters being visible or invisible. So you've got raw data so far. Back up a little bit. You got raw data, which is great, as Tiffany pointed out, because you see every exact value, and that is fantastic. But very rarely do you want raw data to come at your audience. So you summarize. Frequency distribution is one way, and another way is via a histogram. Making sense so far? We will do lots of work with these. I've talked to many statisticians in the field, and they say if your students understand nothing more in Stat 1 than how to understand a frequency and probability distribution, and in Stat 2, if they know what a p-value is, you've done a good job. So I take that to heart. I hear it enough now. I will never let you guys leave these things alone. We'll analyze them a lot in this class. All right. Now, I want to stick with histogrammy type graphs for the remainder of class. I told you, your book is very good about going, here's a box and whisker, here's an ogive, here's a cumulative frequency polygon, here's this, here's this. Now remember that for 8 weeks. We'll come back to it. You won't. But there are other kinds of plots that are histogrammy, but they deal with different kinds of data. So we're going to start with what's called a Pareto diagram. We'll talk about why it's called that momentarily. All right, and I don't have one of these on the PowerPoint because we're going to make one up right now. And I need to collect some data from you all. So I need you to clear your minds. I'm going to ask you a series of math questions. I want you to answer them in your head. Everything I'm going to ask you, I want you to answer in your head. I don't want you to ever call anything out. I'm going to ask you a series of math questions, and then at the end of that, I'm going to ask you a non-math question, and I want you to either write down or just remember your answer to that non-math question. Okay so far? All right, so here comes the math. Clear your mind. 3 plus 3, 2 plus 4, 4 plus 2, 1 plus 5, 3 plus 3, 2 plus 4, 5 plus 1, 0 plus 6, 1 plus 5. Think of a vegetable. There you go. All right, let me hear some answers. What did you think of? Carrot. Okay, how many carrots did we get? How many carrots did we get? We got 1, 2, 3, 4, 5, 6, 7, 8, 9. All right.
Cucumber.
Cucumber.
Asparagus.
Let's get counts too, if you would. Cucumbers. How many cucumbers? We got 1, 2, 3, 4. We got 4. Is it 4? Asparagus. First crop of the year, right? First crop of the year in Bend, anyway. It comes out about April, early May. Perennial, delicious. Asparagus. How many asparagus? There was a male voice that did it too, right? Maybe it was 3 of you guys. Okay, Jared. Good, Jared. Good, Jared. Roxy, Jamie. All right, good. Give me another one.
Potato.
Potato also grows very well here. I just recently realized that the reason Ore-Ida French fries are called Ore-Ida is because the factory's on the border between Oregon and Idaho.
Oh, really?
Did not know that until I drove across Oregon. I'm like, I'll be damned. That makes perfect sense. Who didn't know that until right now? Hey, all right. You learned something else in class today. There you go. But YouTube world, there you go. Potato. One. No, 2? 2 of you. 2 of you. All right. Broccoli.
Broccoli.
Yeah.
No. That's my dean. Let's do broccoli. Broccoli. We got 1, 2, 3, 4, 5, it looks like. I just covered myself. Give me some broccoli again. I didn't think of anything. 1, 2, 3, 4. Okay. All right. So, I'm sure we have a few others because I didn't account for everybody in here. But this always happens. Carrot always spikes. And then things tail off from that. I don't know why. Maybe it's because there's 6 letters in carrot and I kept maybe add a 6, but then explain potato. I mean, potato has 6 letters, right? I don't know. I have no good answer for this whatsoever, except it was sent to me by my mom in an email years ago, and I did the math, and said, think of a vegetable, and I thought of carrot. So I fell right in line with the other 9 of you that did it. Now, the reason I call this a Pareto diagram, we haven't drawn the diagram yet. Let's draw it here in the middle. The reason it's called Pareto is due to the fact that you generally have one data point that exceeds the others pseudo-exponentially. So what you do is you list in decreasing frequency across the horizontal the data. So we've got the most carrots, so we'll put carrot first. And this isn't set in stone. I've seen these done a couple different ways. Sometimes they do it in reverse order. I tend to draw mine so they decrease exponentially. We've got a tie for cucumber and broccoli.
You said list in decreasing, just exponential?
A decreasing order of frequency. So there's mostly carrots. Then we had cucumber and broccoli, and then asparagus and potato. There we go. And then you scale the vertical so that you can actually get these numbers. So we'll scale to 10. It seems like a logical place to put it. Go to 5 here, and 0 at the bottom. And then just draw bars to indicate how many of each were encountered. Carrots 1. Cucumbers at 4. As is broccoli. As is asparagus is at, asparagus is 3, sorry. And then potato is at 2. And you can almost see the exponential curve coming through it. And the reason it's called the Pareto diagram, or a Pareto figure, an Italian, Vilfredo Pareto, actually made a statement called the 80-20 principle. This is back in the 1700s, late 1700s. 80% of the wealth is held by 20% of the people, which is probably more true now than it ever has been before in history. And this was in Italy. So the idea is the lion's share of the data is in 1 or maybe 2 categories. Sometimes I get a bimodal. Sometimes it's carrot and something else, but carrots are always in there, which is pretty rad, actually. Thinking about those numbers that add up. So that's Pareto. And there are variants on it, but the big idea of Pareto is that, number 1, it's in some kind of either decreasing or increasing. It's ordered data. And the other one is what? What kind of data did we just collect? Using terms from earlier today. Oh, it is. We counted it discretely, but it's qualitative, isn't it? I told you to think of a vegetable. I didn't think of a number. I said think of a vegetable, and that's qualitative. We discretely counted it. Yes, yes, but it's qualitative data. So it's a histogram in shape because it's bars, and you got a scaled y-axis. But that x-axis is not numerical like it was for the number of products. So Pareto's allow us to kind of fill that gap for qualitative data to be dealt with histogrammally, if that's even a word. Well, it is now. What the hell? We just made a new word. Cool? Does that make sense? There's a Pareto. There's a Pareto. So it's basically a qualitative histogram, but because it's set up the way it's set up, you get a pretty sweet look at it. Interesting Pareto diagram, if you're interested, is look at oil production versus consumption across the world. Look at the biggest consumers and producers of petroleum, and it's a beautiful Pareto. Please.
I'm a little confused as to why that's qualitative and not quantitative, because didn't you say that quantitative is counted? So
No,
counting them.
but what do we count? I
Okay,
asked you,
what
I
do we
said
count?
think of a vegetable.
Okay.
And your response to that is not a number. You don't say 2
Right.
or
Okay,
5.6.
I got you.
Now, we count the qualitative results.
Okay.
So
But
it's
the
discretely
data
qualitative,
itself
but
is
the data itself is qualitative.
Okay.
Make sense? Great question. Great question. Shireen. I was called Sherry Ann again. Shireen. We're getting there. We're getting there. All right. Now, there's some other ones that look histogrammic. Here's 3 words. Finger, refused, slaughtered. It's a great Swedish punk band. If anybody's into Swedish hardcore punk music, Refused is amazing. Just reactivated after 15 years of being away. They didn't come here to tell you that, even though I just did. What I would like you to tell me is, what is the average number of letters per word in those 3 words? The average number of letters per word in those 3 words. Finger, refused, slaughtered. I'm forcing you to use a term we haven't really talked about yet, which is an average. I think you can do it, though.
8.
We got 13. 6 and 7 is 13, right?
8, yeah.
24 divided by 3 is 8. 8? Okay, good, good. 8 letters per word. When I say average, what do you guys think of? Tell me your name.
Danielle.
Danielle, thank you. Go ahead.
Add together and divide by the.
Excellent.
Yeah.
Add them all up and divide by how many there are. So there's 3 words. We're going to divide by 3. You just add up all the letters, divide that by 3. There it is, right?
Right there.
There.
Right there.
We're going to hit that hard on Monday, and I want to get into I want to ask the question, why do we do that on Monday? We'll ask, I should
Because
ask
in
that
the
now
5th
too.
grade they told us to.
Because in 8th grade they told you so. We'll have slightly better answer than because in 8th grade they told us so. Hopefully. It involves lollipops. We'll get to that on Monday. Anyway, I'm going to show you some more words. And you won't have the time to do what you just did. I'm going to give you 10 seconds to come up with the average. I know, terrifying. So what I want you to do is to give me your best estimate of what the average number of letters I'm about to show you is. And give me a decimal point of accuracy. So this would have been 8.0.
Yeah.
8.0. So give me 1 decimal of accuracy on the words that you're going to see for 10 seconds. You ready?
Oh, all right.
Good. Okay. Your best guess. You're wasting time complaining. Okay. 10 seconds. 10 seconds. Do you recognize the speech?
Yeah.
A couple of yes.
I didn't even read the speech.
I'm not offended. It's only the greatest movie ever made. There's a hint. Here's the gentleman that did the speech, The Princess Bride. Who has not seen The Princess Bride? I am envious of you, because that means you get to go watch it for the first time. And experience the greatest movie ever made. Yeah, fantastic. It was a soliloquy, the 6-fingered man soliloquy from Inigo Montoya. You killed my father, prepare to die. Anyway, that's not what I came here to tell you. I came here to collect your guesses for the average length of a word in his speech. So, let me hear some. Did anybody guess 6-point-somethings? Anybody do 5-point-somethings? Do some 5s? Anybody do 4-point-somethings? 3-point-somethings? Get some 3s? 2s? 1. Okay, so 3's a low ball. Anybody go 9-point-something or higher? 10?
10.
Got a 10? Anybody above 10? Love it. Perfect. We're going to do what's called a stem and leaf plot, or a stem plot, depending on what book you read. The reason these are great, the reason these are great is it's great for collecting data when it's widely scattered in one direction, but concise in another direction. Now, that sounds a little bit weird, But it could be that you're collecting natural resource data on the number of branches in a tree in a certain subplot, or the number of forbs, or the average height of a forb in a certain subplot, where all the forbs are between, say, 3 inches and 12 inches, but you've got a lot of detail between the 3 and the 12, or all the branches are, say, between 3 and 12, and you got a lot of detail between 3 and 12. So we have a lot of detail, I'm guessing, because we're all between 3 point something, it sounds like, and 10 point something. So what we're going to do is we're going to set up our stems, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we're going to call these the stems. And then I like to draw a vertical line. You don't have to. Again, there's some freedom in how you construct these things. Software packages will do it its own way. The leaves are going to be the decimal part of your guess. So those of you guys that did 3 point somethings, give me out your point somethings. Point what?
8.
Point 8? What else?
Point 5.
Point 5? Just those two?
.7.
Point 7? Love it. Be brave. Okay, just that. Some books will require that they're in order. I don't care. There's only one thing I care about, and you'll see it now when we do the 4s. 4s, count them out.
.9.
0.9,
0.3.
0.3,
4.
0.4. Cool. The only thing I care is that however big you make one, you make them all.
So there shouldn't be commas between those?
There can be, but the commas in my mind get confusing with the decimal points. I mean, I know this means that somebody said 3.8, somebody said 3.5, somebody said 3.7. Put the commas if you want. It won't be an issue with whole number values. So for example, if this was 38, 35, and 37, the comma wouldn't be a confusion at all. I just have never gotten the habit of putting commas in. Freedom of expression and how you want to express the data. Totally fine.
Okay.
5s, let's hear them.
0.7.
Okay, I heard 0.5, 0.6,
0.2.
0.7, 0.2, 0.3. Did I get all 5s that said 5? All 5s that said 5s?
0.8.
0.8, there we go. Solid? Let's get the 6s.
0.2.
0.2, 0.2,
0.8.
0.8. That good? 7s.
0.3.
0.3, 0.2,
0.3.
0.3. 8s. 9s. 10s. No, somebody said 10.
I did.
Oh, Tiffany, yes.
Sorry.
That's okay, no apologies.
No.
10 even.
Oh, 10.3.
10.3. I love it, Tiffany. Thank you for that. That's what we call an outlier, and I love it. And I love it. I love the idea that we have an outlier in this data. What I love about the data, too, do you see why I call it histogramming? Do you see why I call it histogramming? If you don't, take your head and turn it 90 degrees to the right. And you'll see it, hopefully then. Because you get, essentially, bars. But this also deals, it's almost perfectly bell-shaped, too, which is pretty sweet. Plus it's cool down here. You pick up the beauty of a histogram with the accuracy of having all the actual data. Kind of slick. That's a little bit better than a histogram, right? Because you actually have all the data in there. And if your computer is generating these on the fly, it's even better, as they often do. They often generate on the fly. Very, very nice. Is that fair? You can also make them stacked vertically. It's just that since we read left to right, a lot of times it's better to have them going this way. Fair enough? Stem and leaf. I call it histogramming because it kind of is histogramming in its own little way. And there's one more histogrammy type I wanted to talk about, but I want to make sure this is okay first. These are called your leaves over here. These guys over here are your leaves. You might also want to have a label on the chart, average length of a word or something like that. But the important thing is to know the function of what's actually going on, what's being measured, or how it's being presented, I guess. And leave these blank. Leaves the 8th and the 9th. Leaves the 8th and the 9th blank. Leave the 8th and the 9th blank, because nobody said 8 and nobody said 9. If you don't leave those blank, if you slide 10 down here, it doesn't make that seem like the outlier that it is. And it's important to note that that's out there. Why was that out there? Outliers, they have a whole, your book doesn't have a section on outliers. As a matter of fact, I had to read all 700 pages a number of times before I found the occurrence of the word, which I think happens twice in all 700 pages. It's mentioned in passing. And I thought that was kind of silly because the very definition of inferential statistics relies on outliers and the presence or absence of outliers. So we'll talk more about how to measure those bad boys in this class. We're nodding our heads. Tell me your name, my friend.
Angie.
Angie, and have you read the book Outliers by Gladwell?
No, but I know that outliers can throw data off completely.
Absolutely. As a matter of fact, if I asked you guys what the average guess you guys had was, without the outlier, it's easy. You guessed about 5.5. But the outlier will actually pull that average this way. And believe it or not, the average is about 4. It's about 4. It's down in here. And the reason for that, of course, is because there are so many short little words in there that each can count at one time. There's a lot of us, I's, I, me, he, I. Lots of little words. Not very many big words like slaughtered, refused, and things like that. And of course, I'm a bastard because the 3 words I gave you as an example were all long. So I biased you a little bit right then by how I presented the data to you, because I'm a big jerk. Cool? Fair enough? Angie, like that point. Thank you very much, my friend. I got one more word to talk about. It's called a dot plot. Very, very simple. A dot plot can be for qualitative or quantitative, and it's when you have very, very few data points to actually plot. So we'll do a real quick example of one. Just generate some real quick data for you guys. I want to ask you one question, and one question. I'll just clear your minds. I want you to think of a whole number from 1 to 4. That's it. Whole number from 1 to 4. That's it. Now, why is a dot plot better than a histogram at this point? How many data values do we have? 4. I mean, it kind of seems kind of silly to make a histogram when you've got 4 data points. So your horizontal axis just goes 1, 2, 3, 4, and then we just put dots above for how many of each. How many of you said 1? 2 of you. So dot, dot, boom. How many of you said 2? 1, 2, 3, 4, 5. You're behaving exactly like the average. How many of you said 3? Oh, yes. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And the rest said 4, but I don't want to count. So how many of you said 4? 22. You guys are pretty much exactly on average. 1 is always underrepresented, 4 is slightly higher. 2 is a mix. 2 is a mixed bag. Sometimes 2 is a little bit higher, but there's always a spike at 3. Why? Why is there always a spike at 3? Oh! I hadn't thought about that, Christina. I had a more nefarious reason. Because our brains just kind of think in 3s, we try set things. I wasn't thinking of that. I should try it with 1 to 5 sometime and see what happens. No, that would probably still be 3, wouldn't it?
Correct the middle, yeah.
Middle. 1 to 10 maybe. I have a theory why 3 gets spiked. What? Tell me your name. Tell me your name.
Shelby.
Shelby, go.
You said give me a number from 1 to 4. You didn't say the number 3, you said the rest of them.
And our brain plugs that hole right away. We like patterns. We don't like clusters. We're very anti-random. I said 1. I said 2. I didn't say TWO. I said TO, but our brains hear TWO. I said 4. You guys say 3 on average.
Yeah.
I don't know. Maybe. Who the hell knows? Please tell me your name.
Nick.
Nick.
What if you said 1 through 4? Would that change the
I will try that next term. I will. I'll try next term and see if it, because through is not 2. And then if we get an even distribution, I'm going to try it tomorrow, actually. Email me to remind me to do that if you would be so kind. Thank you. Just send me a text or an email. Yes. Somebody email to remind me to try through tomorrow on the 243 class at 10:15. I want to close out today. You are not responsible for what I'm about to show you. But I think it represents some of the more artistic ways of presenting data that I've stumbled across in the world. And not everything you learn has to be assessed on an assessment. Sometimes it's just a matter of like, oh wow, that's really cool, and I might learn something from that. So here, see if you can see what this is getting at. If you can't read that text, it's pretty small. It says green, people who live with less than $10 a month. Yellow, people who live with less than $100 a month. Blue, people who live with less than $1,000 a month. White, people who live with more than $100,000 a month. The flag is not entirely accurate. The Portuguese flag